Morning all, my voice is slowly returning. Today I want to just talk about a comment that Hype Gamer put in. Thanks for the lovely messages, by the way. But yeah, Hype Gamer, I was asking why isn't eye tracking in all headsets? Why don't we consider it a default? It seems like an obvious technology. Well, first of all, you got to remember that when we were developing the first generation of headsets, eye tracking was still a lot more expensive and wasn't as good. Eye tracking comes in a range of flavors, and most of the eye tracking tech at the time was either very high-end static stuff for in situ sort of analysis in like labs or user tests. It was you installed it in your lab, and you had people work in front of it, or there was basically a lower end gaze tracking model that was mostly driven by advertisers and analytics companies. So it was very high latency, very slow. Some of the systems were inaccurate, some of the systems were accurate, but they generally didn't have the responsiveness that everyone kind of needed. So for first generation VR, it was just kind of off the table, but a lot of research was being done, a lot of money was being thrown around, because there were a lot of players in the space. And when it came to developing the PlayStation VR 2, which starts a lot sooner than people realize, like, the PlayStation 5 Pro was being developed pretty much the moment the, oh, no, it evaporates too quickly. There we go. Whew. Pretty much the moment that the PlayStation VR 1 was like mostly spec locked and stuff, the like concepting starts, and then the real work starts pretty much as soon as it starts shipping, because lead times on hardware is always longer than people think. Anyway, as we started the PlayStation VR 2 development, and a lot of the others were deving up for the sort of next generation of VR, eye tracking was very much on the table. And there was one company that pretty much everyone was talking to called SMI. I forget their full company name, but they were one of the few established players in the space who had been doing some stuff with VR, because people forget that VR was still ongoing in the research world, it was just not in the consumer world. And there was also some military applications for heads-up displays and things like that. But SMI was like the leader. They had a very low latency solution, was very good. A few companies, started like integrating SMI into their products, into their prototypes and early versions. An early version of a headset, by the way, if you're developing from scratch, because a lot of people don't know that like pretty much all the Android headsets, while like Meta and stuff has a big say in them, they're mostly based off a reference Qualcomm design, and Qualcomm does like the bulk of what would be considered the hardware engineering work. And that's why like the Pico headset and the Android and stuff, they've got such similar internals, because they're all based on a Qualcomm reference design. But yeah, if you're in like PlayStation, or if you're in Qualcomm or somewhere where you're developing, not from a reference design from scratch, the early headsets were like strapping laptops to your face. They were like hand-wired, gajiggered monstrosities. But the early first SMI demos were very powerful and very cool, and a lot of people had signed contracts with SMI at the time. Then what happens, sorry Mo, and I've got some water here to put out fires. But then what happens is Apple, who at this point is starting their own VR work, and bear in mind this is a while back. This is like 2015, 2016, I forget. They decide, oh, we're going to buy SMI, and everyone's like, oh, that's fine. We've got contracts with SMI. And Apple's like, no, we don't want anyone else working with SMI, so we're going to pay the breaching fee on these contracts, and we're going to stop all of these contracts. And this freaks out the whole VR industry at the time, and pretty much everyone in the VR industry except Apple sort of agrees to find the next supplier of resort who's like closest to SMI, rally around them and protect them in sort of it's a complicated web. It's not like everyone got around and agreed no one, sorry, someone's, oh, it's a truck backing up. I thought someone was constantly burning toast or whatever. Anyway, so they all basically come up with these complicated contract agreements and everything that are all basically structured so no one, including themselves, can buy Toby, which is the next sort of player that was closest to SMI at the time. But it's no exaggeration to say that Toby's eye tracking tech at the time for VR was awful. It was just not what everyone needed. And so everyone basically, but it was the closest to SMI. And so everyone basically threw a ton of money behind Toby to sort of up their thing. A lot of internal resources from Meta and from Sony and from a bunch of players were thrown into eye tracking on VR. And it gets complicated because of patents and bullshit, but the short version is the industry kind of rallied around Toby, and everyone was like, okay, this is the solution. And so that happens, right? Now, there's also a bit of a complication here in explaining how headsets are built. Oh shoot, I didn't mean to go through the portal just yet. I was trying to get that. Oh well. And how headsets are built and such. Component and hardware manufacturer, I am no expert. I have exposure to it through the consumer side, in the sense of like a B2B relationship of like developing hardware and things. But needless to say, you build stuff in components as much as possible. You try to use the same components as everyone else. And you try to componentize your design as much as possible for a bunch of reasons. And for all of these reasons, the standard optics stack, even if an optics is like bespoke to your company or your headset, there are good reasons to have your optics stack like isolated. So this is like, if you open up your VR headset, you'll see that there is two like blocks usually, and each block has a lens and a display in it. Some of the older headsets, there was a single block with a single display and the lenses and one and half another other. And so, because, you know, developing hardware is difficult, it's a constant effort in cost analysis and keeping your options open, because it takes years and years to develop, and you don't necessarily know where certain tech's going to be, where certain hardware is going to be. And like for eye tracking, at the time of developing a lot of the core optic stack stuff, eye tracking wasn't there yet for a lot of people for Toby. And so the obvious decision to, you know, people thought it would be there, but the obvious decision to minimize risk was to make it not a core part of the optical stack. And so pretty much everyone except for Apple, who had like acquired TMI, made the decision to build it in such a way that eye tracking could optionally be added in the factory. Like not optionally like, oh, we want, you know, it in blue or whatever, but like, you know, the SKU is more configurable. A SKU is industry term. I forget what it is, single something. Anyway, so I'm distracted by this guy. So anyway, we put it on the outside, and for those of you who don't know how eye tracking works, there's a bunch of different versions of the technology. Your eyeball is best described as a freaky loose glob of jello that wants to kill you, and is designed, well, not so much designed as thrown together by an idiot genius, because your eyeball is really great in some ways and awful in others. And like when you look at eye tracking, you think you're tracking like a solid ball that's rotating, and yeah, no, it's much more like a jello glob that, oh god, I do not have the wands for this level. It's much more like a jello glob that stretches and does all kinds of, oh god, I'm not going to live. Stretches and wobbles, and like if you move your eyes left to right, there's a whole bunch of like aftershock motion in your eye. And to get good eye tracking, you're tracking things at like thousands of hertz. You're doing a lot of like signal processing on specialized chips, and you know it's bespoke, weird, difficult hardware. Ow, bollocks. We'll start another quick one so I can finish this this conversation. So anyway, pretty much everyone agrees, hey, we've got to sort of hedge our bets because we don't know if eye tracking is going to be ready, and this is across the industry. But this is also why pretty much everyone is using the Tobii solution, and the Tobii solution looks very similar for most SKUs, where it's like a strip of LEDs outside, some dedicated signal processing, and then cameras on the outside ring, and they track through. Whereas look, if you look at the Apple solution, which was developed by SMI, because they knew they had it the whole time, they actually they're sending that IR light through the optical stack, like through the lens, and they put a lot of their cameras and stuff inside the optical stack. So yeah, interesting things. But the heart of the question was, you know, why doesn't all VR stuff have it? Well, first of all, hopefully this conversation's made it obvious to you how difficult the development and how recent the development of a lot of the eye tracking stuff is. But then the other problem is, and this kind of reminds me of the old PlayStation 4 situation, is cost. So much of developing hardware is figuring out what is going to be useful, and it feels really obvious to you when you're in an armchair and you're going like, oh, obviously they should do this. It's like rewind your brain 5 years and make that same prediction and bet millions on it. You know, that's the difficulty of hardware development. And yeah, so, you know, with the PlayStation 4, the classic one was, you know, whether or not to put the PlayStation camera in the box or not. And that decision, funnily enough, tracks to about $100 or £100 roughly. And the decision not to put the camera in the box meant that the PlayStation 4 could be $100 cheaper than the Xbox One, which had to have the camera in the box. And that's a big price difference. Like, that psychologically moved it into a different price category. And a similar thing happens in VR, and ironically the numbers are roughly similar in that adding eye tracking to a headset, I mean, obviously it's going to vary and stuff, but it works out to roughly 100 quid for a basic eye tracking solution. Good enough that you can do foveated rendering with it, which is like the baseline of what you need for VR. And so because of that, it's, you know, most of it is a price discussion. But then it's not just a price discussion. For standalone headsets, a big part of the discussion becomes battery life and becomes thermals, because IR light doesn't generate much thermals, but it generates some. Cameras can run quite hot, and then the signal processors can run very hot, you know, depending on how you clock them and such. So keeping things cool when you shove a headset on is a big part of the problem space, and then not draining the battery is another part of the problem space. So not only are we talking about an additional, say, $100 onto the headset's price, we're talking about less battery life and potentially having to underclock certain parts of the CPU and GPU so you can keep your thermals within safe ranges. So yeah, eye tracking becomes a really difficult decision, and until Apple shipped their best-in-class eye tracking solution, I mean, I will say PlayStation VR 2's eye tracking is really good. Yes, everyone's using Tobii, but the decisions on implementation and how you plug it in makes a big difference. And yeah, if you want to see really solid eye tracking, I'd recommend PlayStation VR. I'd say it's at Apple quality. So we got there, which was not easy. But yeah, so that's, you know, and only now, and the other problem is because so few people develop games exclusively for the PSVR 2, very few games can make eye tracking a core part of their game. I always point to Synapse, the roguelike shooter with the telekinesis, as one of my favorite examples, because its core gameplay relies on eye tracking, and it really makes a difference. It really feels good. And obviously everyone's played with the Apple headset and knows how if you build your menu systems and stuff around eye tracking, you get a lot of bang for buck. There's a lot of trickery in the Apple headset, which could also just be described as really good software design that hides the limitations of eye tracking, because it does still have them, quite a few of them. But it's very good tech. But yeah, eye tracking, I think, will be a strong part of future VR hardware, but I think will not be a base level feature for a long time because of the price discussion. And because it won't be a base level feature, it's going to really slow its deployment, because the developers can't depend on it being there. And that's, I cannot understate how much of a thing that is, developers knowing whether or not you can rely on a thing being there. So it's a tricky situation. You know, I think PlayStation, you know, it could be argued made the wrong call to put eye tracking in. I love it as a feature, but the fact that PlayStation put eye tracking in meant the price had to go up 100 quid. And I think if you look at the launch price of the PlayStation VR 2 and you said, well, it's 100 quid cheaper, there's potentially a strong argument to say that that does a lot better. But, you know, we thought the market could bear it, and we were wrong. But yeah, so that's why eye tracking. Eye tracking comes down to cost, but it's a lot more complicated than that. And I hope this gives you a bit more insight into that. Yeah, keep the questions coming. It's always good.